In this video, I'll show you how to use fuzzy logic control using KnowledgeScape. Basically, what we have, for example, in a flotation cell is the classical level control, and now we have mass pull control. And today I'm going to simulate the froth velocity control, which is acquired with a camera, and that controls the airflow into the cell. Usually the velocity of the froth is from 0 to 20, and the valve opening will be considered from 0 to 100%. For that, we will create some settings for the fuzzy logic, and we will consider three sets: low, medium, and high. And that will be the values for the three sets for the process value, which goes from 0 to 20 centimeters per second. And for the case of the valve opening, we will have as well these three settings: low, medium, and high, and going from 0 to 100% opening of the airflow valve. For that, we will create some nodes and attributes, some fuzzy rules, and also an encoder to simulate the process. In this software is this screen. So the first thing you do is create a server. I just will call it tutorial, and then I will start the connection. It's got connected, and now that it's connected, it's not, so I will add a node, call it row. Inside this node, another node, call it air. Inside froth, I will create three attributes. The first will be the froth velocity process value. Another attribute will be the froth velocity set point, and another attribute will be the error. I will call delta, and then inside the R I will add an attribute, call it flow, the airflow. And now I will create now the fuzzy set. So the first fuzzy set will be called low, enter, and now that will be from 0 to 2.5 and 5. Another fuzzy set, call it medium, which will be going from 3, 6.5, and 10. And then another fuzzy set called the high. And this fuzzy set high, we will have the values between 7, 13.5, and 20. Okay, then we have four settings for the process value. And now for the airflow, we will need as well, this is our low level. In the low, we will have values 0, 20, and 40, and going to 100% valve opening. So I will put those values, I will fit those values, so 0, 20, 40. For another fuzzy set called medium, will be from 30 to 50 as one, and then going down to 0 will be 70. So let's create another set color, let's high, and that would be between 60, 80 and 100. Let's accept that. And now what we'll do is create some rule script. So we create a rule, call it script, call it default. Inside default, I just will copy this code, which I will explain how that works. So that's my code. I will accept. So always you should accept. So in my code it says that my float velocity set point will be 8 centimeters per second, and this value will be just for the simulation, and this value is the error, a normalized error. That's why I'm divided by the maximum value, which is 20 centimeters per second, the float velocity, and that will be normalized from -1 to 1 just. And later here I will, using this 20 multiplied by 20, I am denormalizing this value, and in this so this is a proportional control to simulate the process. So what I've been doing is just the 100% opening will be going directly proportional to the float velocity. The error and this K factor, the proportional factor, you just put in the maximum of each one. I mean from the float velocity and the valve opening. And just I told you, this is just to denormalize from -1 to 1 to -20 to 20. Okay, then the next thing is to add a scan group. I will scan this to 5 seconds, and this is, that's it. Now we can go for trend. We can train these values, and I will put just the process value, the set point, the delta value, and also the airflow entry into the cell. And now what I will do is just check the values, the scales from 0 to 20, the process value, the same for the set point, 0 to 20, and the color will put red. It's okay. And here in the delta value, the error will be from -1. I normalized that one, so it will vary from -1 to 1. And the color of this, I will put just a green color, and for the airflow will be from 0 to 100%, and I will put just royal color, and that's it. Let's check this to 10. Let's scale and see how it works. As you can see here, the process value, the black one, is correcting to the set point, to the series set point, and the error, which is the green, goes to 0 once it's reaching the set point value. So that is working the control, and the airflow went a little bit up. Now what we can do is change, for example, this set point to 17. Accept. We will see the trend, how it goes. So now change it the red, which is the set point, to 17, and immediately the airflow, which is the blue one, is going up. So immediately the process value is achieving the set point, is reaching the set point value. I can put scale points, you can see. As we can see, this is the there's almost there. It's reaching the set point. The process value is reaching the set point, and the airflow is going up, and the error is going down to 0. So let's see, the error is going 0, and the process value is almost close to the set point. So that's how it works. So let's enter another disturbance. So I will add a rule, call it disturbance, and this disturbance I will schedule to 60 seconds, and in the script I will just copy the disturbance I prepared. So the disturbance, basically what it will do is the process value will be added some random value between -2 and 2, so it can change. This is a disturbance, so we will let's check in the trend how that works. And let's put back to 10 minutes. Let's see the disturbance how goes. Yeah, let's see. The black line should have a disturbance. What I will do is put a value different. Let's say 6 at set point, and let's see how. Yeah, we see this disturbance here. The disturbance. So anyway, I will check later a much better value. So right now my set point, I put a value at 7, the red line, so immediately the process value is reaching the set point, and you will see that's the error, and also the error is diminishing, and it's trying to correct. The error is going close to 0, while the process value is reaching the set point. So that's what is happening is this variation that occurred was the disturbance. Remember, we were in the rule script, in the disturbance we put this random value between -2 and 2 added to the process value. So that's this disturbance. So let's see another disturbance. So the disturbance will happen every 60 seconds from here to here, 60 seconds, and let's weigh another disturbance. Probably it's too small, the disturbance here. We will change it to see a higher disturbance, let's say -5 and 5. Except, and we will see trends at the higher disturbance. Let's see. Okay, you see, it starts the disturbance. We can put the scale 5 minutes, and you will see this is a disturbance effect, and immediately appears the error, and also immediately start correcting the airflow, reducing the airflow so that it can be corrected. So right now it's reaching, the process value is reaching the set point.